Number 1 says this year students in 9th grade are collecting dimes and quarters for a school fundraiser. They are trying to collect more money than the students who were in the 9th grade last year. The students in 9th grade last year collected $143.88. Use D to represent the number of dimes collected and Q to represent the number of quarters. Which statement best represents this situation? So we want more than this amount of money, right? So we want to collect more than they did last year. And so when we're looking at how we put this together, right, we want dimes, which we know dimes are 10 cents. So that's going to be 0.1 times however many dimes we collect. And then quarters are 25 cents. So then 25 cents as a decimal is 0.25, and then times the number of quarters we collect. And we want that to be anything greater than $143.88. So we do not want it to equal that. We want it to be just greater than the 143.88. So when we take a look here, we see this equal sign underneath these two. So these two are automatically out. So now we're looking between C and D. And when we look closer here, we say that this one says 25 cents for dimes, and that's incorrect because 25 cents is how much a quarter is. And then 10 cents for the dime, that's greater than the total from last year. So D would be our correct answer. Number 2, a farmer is creating a budget for planting soybeans and wheat. Planting soybeans costs $200 per acre, and planting wheat costs $500. So we've got soybeans at $200, wheat at $500, and he wants to spend no more than $100,000. So that means if we're not going to be more than, we're going to be less than or equal to. Okay, so does not want to spend more than $100,000, so he can spend less or equal to $100,000. So let's write an inequality that describes these constraints, and we want to say what each variable represents. So I'm just going to call S the acres of soybeans. And then the other one we have is wheat. So I'm just going to call that W, and that will be our acres of wheat. So we're spending $200 per acre of soybeans. So 200 times however many soybean acres we plant. And then we're going to add on $500 per wheat acre that we plant. And we need this to be less than or equal to $100,000. So then you want to just come up with one solution that will work to this. So just pick any numbers you want for S and W, and just make sure that they get you less than 100,000. So I'm just going to pick some random numbers here. Now we could obviously, if we want this to be less than $100,000, we could put in some pretty small numbers, right? You could just do 1 and 1. That's for sure going to work. I'm going to do something maybe a little bit bigger than that. So let's try 100 here, and then let's try, so let me see how much that's going to be. So if we do 100 soybean acres, that's 200 times 100. So this is going to give me $20,000 that I spent on soybeans. And then let me do maybe 150 acres of wheat. So then 500 times 150 gives me 75,000. And we just need to check that that total is less than or equal to 100,000. So when I add those together, 20,000 plus 75,000, I get 95,000, which was pretty close to that 100,000. But still less than 100,000. So that is a solution. So this 100, 150 is a solution. So this one works. And then what it represents in the situation is that I planted 100 acres of soybeans. and I planted 150 acres, whoops, of wheat. And now you could do, a bunch of different numbers, but when you plug these in, the total after you multiply by 200 and 500 just has to be less than that 100,000 or equal to. Number 3, Elena is ordering dried chili peppers and corn husks for her cooking class. The chili peppers cost $16.95 a pound, and the corn husks cost $6.49 a pound. She needs to spend less than $50 on the dried peppers and the corn husks, and then they define the variables for us here. So they tell us that D is going to be the dried chili and H is going to be the corn husks. Then they give us a graph of it over here, and they say write an inequality to represent this. So remember that we have a certain number of pounds of dried chili peppers, and those are costing us $16.95. And then we have a certain number of pounds of corn husks, which they're calling H, and the corn husks are $6.49 a pound. And then we need this to be less than, so she wants to spend less than $50, not equal to 50, but less than $50. The next one asks us, can Elena purchase 2 pounds of dried chili peppers? So remember, we've got $16.95 times the number of dried chili pepper pounds. And then we've got $6.49 of the husks, and that needs to be less than 50. So here they're saying, can she buy 2 pounds of dried chili peppers and 4 pounds of corn husks? So do $16.95 times 2, which gives us $33.90 on dried chili peppers. Then we're going to do the $6.49 times 4, and that's going to give us $25.96. And so when we add $33.90 and $25.96, we get $59.86, which is not less than the 50. So she cannot do this. Okay, no, because it's more than the $50. Then the next one asks us a different set of things that she can buy. So let me just, pull this down here. And so this time it's asking us if she can purchase 1.5 pounds of chili peppers and if she can purchase 3 pounds of corn husks. So now we'll do $16.95 times the 150 or 1.5, sorry, 1.5 pounds. So she's going to spend $24.42.5. So this is, we'll just round it up to 43 cents. And then $6.49 times 3 is $19.47 on the corn husks. So then we'll add those two numbers together, and we get that would cost her $44.90. This is less than the $50. So yes, she can do this because she's spending less than 50. Number 4, which inequality is represented by this graph? So one thing I look at is that this is a dotted line, which means that we shouldn't have an equal sign. And so when we look here, we don't see anything with an equal sign under it. So that didn't help us narrow down our answers. Then if we take a look at these answer choices, we'll see that each of these answer choices is written in standard form, meaning it has the X and the Y on the same side and then the number on the other side. So this is helpful in finding the X and the Y intercepts because we can just plug 0 in. So if we're finding the x-intercept, we plug 0 in for y. So then we'd have 4x equals 12, divide by 4, and we would get the x-intercept equals 3 for these first two because they're kind of the same equation. And then if we wanted to find the y-intercept, we would just plug 0 in for x. So then we'd be at negative 2y equals 12. So we'd divide by negative 2, and we'd get y equals negative 6 for these ones. Now, this is just for these top two that have the same numbers. And so if we take a look here, this x-intercept is at 3, and the y-intercept is at negative 6, so that's matching. Versus down here in these two, if we found the y-intercept, we would end up with positive 2y is equal to 12. And so when we divide by 2, we would be getting positive 6, which is not where the boundary line is crossing at. So we know that C and D are incorrect right away. So then we just have to figure out where the shading is. And I like to plug in the point 0, 0. And in this case, 0, 0 is in the shaded region. So we want a true statement. So when we plug in 0, we'll get 4 times 0, which is 0. And then negative 2 times 0 is 0. And so then 0 minus 0 is 0. Is 0 greater than 12? And that is false. So this is not going to be our solution. 0 is less than 12 is true. And we know that we want this point to be in our solution set. So B would be the correct choice there. Number 5, here are some statistics for the number of minutes it took each of 9 members of the track team to run a mile. When a 10th time is added to the list, the standard deviation increases to 1.5. Is the 10th time an outlier? So then it asks you to explain your reasoning. So you might tackle this a few different ways, but one thing about the outlier is the outlier needs to be 1.5 times the IQR away from your quartiles. And remember that the interquartile range, or the IQR, you find by taking Q3 minus Q1. So if we subtract these, so if we do 7.4 minus 6.8, we get that the IQR is equal to 0.6. So in order for this to be an outlier, we would multiply 1.5 times the IQR. So 0.6 times 1.5, and we would get 0.9. So I just multiplied this by 1.5. So in order for it to be an outlier, okay, we'd have to have 6.8 minus 0.9, which is 5.9. So the number would have to be less than 5.9. And maybe I'll write this out horizontally so it maybe makes a little bit more sense visually. So, if this is your Q1, okay, which is 6.8, if it were an outlier, it would have to be 0.9 away from this. So if we subtract 0.9 from here, we'd be at 5.9. Then our Q3 is up here somewhere at 7.4. So in order to be an outlier, it would have to be 1.5 times or plus 0.9 above that 7.4. So up here at 8.3. So your outliers are going to be outside of this. So any numbers, outside of here. Now, the other thing to take into consideration is what a standard deviation means. And a standard deviation means, we just add 1.1 to this median, and that's going to put us at, well, in this case, let me see. So if we add 1.1, So 1 standard deviation away is going to be at 8.2. And 1 standard deviation this way, so if we subtract 1.1, we'll be at 6. And most of your data is going to be within 1 standard deviation. Okay. And then a good chunk more is going to be another standard deviation away. So since these two numbers are super close together, right? 6 and 5.9 are pretty close, and 8.2 and 8.3 are pretty close. It's unlikely that this is an outlier. Okay, so unlikely that that's an outlier. Now you'd have to, make sense of my chicken scratch and write that better in your student workbook. But this kind of area here is your 1.5 times your IQR. So anything within there isn't an outlier, and then most of your data is within that 1 standard deviation. And I just added 1.1 and minus 1.1 from the median. So it's unlikely that it's going to be that. Number 6, Elena is solving this system of equations. She multiplies the second equation by 2. Okay, so I'm going to do that right here. So 5x times 2 is 10x. Negative 3y times 2 is negative 6y. And then 8 times 2 is 16. And then it says, to her surprise, she gets an equation of 0 equals 0, right? So she does 10 minus 10 is 0. Negative 6 minus negative 6 is 0. 16 minus 16 is 0. So what is special about this system of equations that did that? And so why did she get that result? And so the reason that she got that result is that these equations are equivalent. So when she multiplied by 2, she ended up getting the exact same equation, right? So the equations are equivalent. So then this means that there will be infinite solutions. And this is because every solution to the first equation will have to also be a solution to the second equation since they are equivalent. And then it says you can try graphing them too if you wanted to. And so if you graph them, what's going to end up happening, and this isn't going to be the graph of them, I'm just going to sketch it for you. But what would happen is if you were to do this, you would end up with, and let me get it somewhat right. Okay, so it's going to be a positive slope. So you'd get one equation like this, and then when you graph the second equation, it would be like this. They would just land right on top of each other. So they give you the exact same line. So if it's a solution to the orange one, right, it would be, which is under there, it would be right here, which then that is also sitting on the blue line. And if you had a solution to the blue equation, okay, it's also going to be a solution to the orange under there. So that's why there's infinite solutions. Number 7, Jada has a sleeping bag that is rated for 30 degrees Fahrenheit. This means that if the temperature is at least 30 degrees, Jada will be able to stay warm in her sleeping bag. Write an inequality that represents the outdoor temperatures that in which Jada will be able to stay warm. So the temperature outside needs to be more than 30 degrees or equal to 30 degrees, and then Jada will be warm. So then we want to write an inequality that represents the temperature at which she needs a thicker or a warmer sleeping bag. So if the temperature is not greater than or equal to 30, so if the temperature is less than 30 degrees, then she's going to need a warmer sleeping bag. Number 8, what is the solution to this inequality, the solution set? So I'm just going to write it down and do some simplifying. We're going to solve for the boundary. So I'm just going to switch in an equal sign here. And then we've got parentheses and multiplication. So I need to distribute the 3 in. So 3 times 2 is 6. And then 3 times negative 1x is negative 3x. And then we still have the plus 6x and the minus 2. So I'll write this part down, and then I'm going to combine like terms over here. So I've got, and maybe I'll use a different color to show these. So I've got 6 with negative 2. Okay, so 6 plus a negative 2 is a positive 4. And then I've got a negative 3x plus a 6x. So negative 3x's plus 6x is a positive 3x. Then I've got all my like terms combined on each side. So now I need to get them together on the same side. So I see these x's here. So I want to subtract this 3x to make it 0 so that it comes off of this side. And what I do to one side, I need to do to the other. So 6x minus 3x is 3x. We still have the minus 20. And then equals 4. And then 3x minus 3x is 0. So then I want to deal with this negative 20 because that's a like term with the 4. And so negative 20 plus 20 will give me 0. And then I need to do it on both sides. So then we get 3x on the left plus 0 because negative 20 and 20 is 0. And then 4 plus 20 is 24 on the right. And then we need to get x by itself. So if 3x is equals 24, then I want to divide that 24 into 3 equal pieces, in which case we get x equals 8. Now, this is your boundary point, okay, because we had an inequality up here. So this is your boundary point at 8, and now we need to figure out which way we want to be doing our shading. So we know that this just says greater than here, okay? It doesn't have an equal sign, so it's not going to equal to 8. Then you can plug in any number you want on either side of 8. You know I like to plug in 0, so that's what I'm going to do. And 0 is down here, less than 8. So we're going to plug 0 in. So 6 times 0 is 0 minus 20. And then we're going to see if that's greater than when we plug it in here. So we're going to do 3 times 2 minus 0 is 2. And then we still have plus the 6 times 0, which is just 0. So I'm going to get rid of that plus. And then we have minus 2. So I just plugged 0 in for all the x's. So then we have negative 20. Is that greater than 6 minus 2? And 6 minus 2 is 4. Is negative 20 greater than 4? That's false. So that means 0 is not in our shaded region. So our shaded region is over here. And that means that we want our numbers that are greater than 8. So we have the numbers shaded that are greater than 8. Number 9, here's the graph of this equation. Are these 2 points solutions to the equation? So we can do this a couple of ways. Since they're giving us a graph, let's use the graph. So we want to go to 1.5, negative 4. And we see that that one's on the line. So that is a solution. I always like to double check by plugging it in. So doing 2 times 1.5 minus 3 times negative 4 and making sure that that equals 15. So 2 times 1.5 is 3. Negative 3 times negative 4 is positive 12. So 3 plus 12 is 15. That equals 15. So that's good. So that one is a solution. Then is 4, negative 4 a solution? So we go 4 in the x and then negative 4 in the y, and we can easily see that that one is not on the graph. So we know that that one's not a solution. So we could say this one is on the line. So it's a solution, and this one is not on the line. So that one's not a solution. Now, part B asks us to check if each of these points is a solution. And then part C actually asks us to shade. I'm going to shade first because I'm doing 4 different points that I want to know if they're part of the solution. So I'm going to go ahead and plug in 0, 0 to this to see if that's in the shaded region or not. So 2 times 0 is 0. Negative 3 times 0 is 0. And then is that less than 15? So is 0 less than 15? Yes. So that means that above here is my shaded region. Okay. Then also we see that it's just a less than. So that means that this is a dotted line. That means if anything lands on this boundary, it is not part of our solution set. So then what that enables me to do is then go and check these points. So 0, negative 5 is here on the line. So this is not a solution because it's on the line. 4, negative 2. So 4 in the X, negative 2 in the Y is in that shaded region, right? Because it's above the line. So this one is a solution. 2, negative 4. So 2 in the X, 1, 2, 3, 4 in the Y is below the shaded region. So that is not a solution. And then 5, negative 1. So going over to 5 in the X, negative 1 in the Y is in that shaded region. So that is a solution. And then are the points on the line included in the solution region? And no, because those points would equal 15 and they need to be less than 15. All right, then finally, number 10, a store sells notepads in packages of 24 and 6. The organizers of the conference need to prepare at least 200 notepads. Would they have enough notepads if we had 7 packages of 24? So 7 packages times 24 notebooks and 1 package of 6. So then plus 6. 7 times 24 is 168. And then plus 6 would give us 174 notebooks, which is not 200 or more. Okay, so it needs to be at least 200. So this would be no, because 174 is less than the 200 that we need. So then this next one asks us, what if we had 5 packages of 24 and we had 15 packages of 6? So 5 times 24 would give us 120 notebooks, and 15 times 6 would give us 90 notebooks. This equals 210. This is good because 210 is greater than or equal to the 200 that we needed. So that'll give us enough. B says write an inequality to represent the relationship between the number of large and small packages of note cards or of notepads. So I'm just going to call the large L and the small S and write this. So remember, in the large packages, we have 24 notebooks per large package. And then in the small packages, we have 6 notepads. So 24 per large plus 6 per small. And we needed to have at least 200, which means we needed to have 200 equal to 200 or more than 200. Then it says use graphing technology to graph a solution set. So I just graphed this on Desmos so we can take a look at it. then use the graph to name two other possible combinations of large and small packages. And one thing I should note if you're graphing this in Desmos is just change the X to an L and the S to a Y so that you can actually get an equation there. So now it wants us to name two other combinations of large and small packages that would work. So you just need to pick anything in the shaded region here, anything greater than this line. So any points here. So 10 large and 30 small would work. Because remember, I changed the X to the L, and the Y is the S. So 10 large packages and 30 small packages would work. Or even 30 and 10 would work, because here's 30 for X. So 30 large and 10 small would work. But literally anything in this region, obviously not negatives, right? So we can kind of ignore all that other stuff because you're not going to buy negative packages. So you want to stay within this zone, right? None of this makes sense because you can't buy negative packages of paper. And same here, you can't buy negative packages of paper. So don't look at any of that. You want to stay in this region.